My name is Roman. I'm here with Ramya, and today we're going to be talking about building large-scale data-centric applications with Silverlight. Also, I'd like to make a mention to Wade Wegner from Microsoft. Thanks, Wade, for recognizing our work and actually having us out here and coordinating everything. Okay, so a little bit about what we're going to be talking about is a product line for CT Corporation. For those of you who don't know what CT Corporation is, it's a company that does a lot of legal services. Things like helping you form your company or making sure your corporation is in good standing. Where HQ fits into all of that is that it actually is a tool, a web-based application that allows users to manage those corporations, to do things like manage contacts, personnel, insiders, owners, all of those kinds of things, and actually, and then stock transfers and all that, and actually submit that to the SEC. On top of that, there's a lot of content and collaboration between the users, and there's a good, strong permission and role-based aspect to all of this as well. So this didn't actually happen overnight. HQ has been a product in production for more than 5 years. And over that time, it's actually grown to be about 300 ASP.NET pages. It's built in with ASP.NET 2.0 and with an Oracle backend. It's deployed using multiple subsites, subdomains, virtual directories. Very standard kind of deployment. Also, it's got 30 batches and Win services. And it's got about 200 tables that had to be moved over and migrated to SQL Server, 400 stored procedures, and 500 selects. So as part of this project, it's actually a full refresh of this application using Silverlight. So we actually have built over 300 Silverlight pages. We've actually integrated a lot of our existing, some of our existing ASP.NET websites with this Silverlight application. HQ is very data-centric. Grids, searches, master detail scenarios, many of those kinds of things that you see in a line of business. We have printing, reporting, all that kind of stuff. And as a matter of fact, as part of this, we've actually also migrated the backend from Oracle to SQL Server. So the effort is actually, in terms of size of developers, the effort is actually 70 developers and 18 calendar months. Right now we have about 14,000 active users. And as always with a web-based application, we have to have 24/7 availability. So, what you should expect from this session is we're going to have a really candid and frank look at all the challenges that we've had to actually accomplish this task. We're going to talk about how we've actually packaged the application. We're going to talk about some of the libraries that we've built to support this development. We're going to talk about instrumentation, some client configuration ideas, how we employed MVVM, and some lightweight service discussion. And we'll conclude with how we deployed some web service. And if we have time, we'll appoint some of the other areas that we would love to have discussed. But given the amount of time that we have, we felt that these areas are good. If we want, we can obviously talk after this. So with that, I'm going to hand over to Ramya to discuss packaging, how we packaged this large Silverlight application.
Hello, everyone. Welcome here. So the first thing, let's talk about how we ended up packaging our web application. So now we had some design considerations to start with. The first is the download time. Now, when our users go in and type the URL in the browser, the first thing that gets downloaded is the zap. And obviously, we want this process to be as quick as possible, which means we should reduce the size of that zap. Now, what are the components in a zap? We have XAMLs. The numbers make a difference. The size of the XAMLs, the size of the code behind, any helper classes, any additional DLLs that we reference out to, any third-party DLLs. So with all this, we need to look at all these components to see how to reduce the zap size. Now, the second consideration is browser working set size. The application is going to run in the user's machine, which means that it's going to take memory from the user's machine. It's obvious, it's very fair to assume that the user would have multiple other applications of his own running on that box. It's also possible that our application itself could be run in different browsers, different tabs. And it's important that we keep the browser working set size down so that it doesn't take up too much memory on the user's box. Another thing to consider is in the Silverlight world, it becomes a long-running application. Now, what do we mean by that? Once the Zap is downloaded, let's say we have about 50 screens in that application. As long as the user is browsing within those 50 screens, the app domain is in the memory. It's not going to get it's not going to go away, and therefore, any resource leaks or any such issues, they just compound, they build up because it's just sitting there and not recycled. So it wouldn't be nice if, let's say, periodically we are able to recycle the app domain as part of our packaging model. Last but not least, maintainability. What we need to do, I mean, obviously this application is probably going to live for the next 6-7 years before we end up refreshing it. And it's important that as we keep adding features, the packaging model lends nicely to maintainability. And that's a very important consideration for us. So with all these considerations in mind, we started off with various different models. The first one that we did was what we have by default out of the box using the default project tools and templates. So we took our 300 plus XAML screens, packaged them into one Silverlight application. We had any referenced out any DLLs that we needed, any third-party DLLs, our Silverlight class libraries. And when we build the whole thing out, what did we get? One huge Zap. Let's see how it stacks up to the various criteria that we laid out earlier. Initial download time, unreasonably large because the Zap size was very large. The browser working set size was large because once the huge Zap gets downloaded, the users typically stay in our application all day long. And so the app domain is never recycled. So the browser working set size keeps building up. Any types that get loaded stay in memory. So it's just a huge impact, and it gets worse as the day progresses. Again, impact of long-running app, since the application stays in memory all day, any resource leaks get compounded, and it's impacted. Maintainability, of course, is difficult. As we go on and add more and more features, we have to add additional XAML files into this Zap, and it's just going to get bigger. All the other problems that we saw earlier are going to just get compounded. So we moved on. We looked at the second packaging model that we have. And what we did here was we sectioned out some of the core XAML pages that we felt are necessary for, to start up the application, the initial home page, other such assets that we felt were core, and we put all of those into one Zap. All the other functionality, the other XAML pages, the other functionality was sectioned out into independent module-specific class libraries. And as the user navigated the application, we downloaded on demand any of the DLLs that we needed. Now, how does this model stack up? We had a good control over the Zap size. We were able to figure out, section out a small enough number to reduce the initial download time. However, because it's all DLLs and everything remains in memory, there's no app domain recycling in this model too. So basically, the browser working set size and the impact of the long-running application didn't go away. Likewise, any maintainability, since everything gets added to one of these DLLs, the maintainability is an issue because the browser working set size and the long-running application impact is not mitigated. So we moved on to the third model that you see on screen, what we call the multi-Zap model. In this model, what we did was we took our entire business application and we sectioned it out into various Silverlight applications. Each independent Silverlight application had module-specific DLLs. Module-specific assets. When we say module, that's just different various sections of our application. We call each of those sections a module. And what we did once we sectioned it out, now what do we have here? Any module-specific XAMLs, any module-specific helper classes, any libraries, all that gets packaged in independent Zaps. Any common DLLs, such as maybe we have some user controls that we want to use across the application, these get packaged into independent libraries, which then we keep out of the Zaps by using assembly caching. How does this model hold up to the design criteria? Now, since we have a very good control over the Zap size, the initial download time is very much under control. The browser working set size is under control because each individual Zap is, each module is its own individual Silverlight Zap, And because of that, as the user navigates across modules, the app domain gets recycled. And because of that, the browser working set size is under control. Any issues with resource leaks, etc., are mitigated because the app domain keeps getting recycled as the user navigates our application. And we have our maintainability very much under control too, because as we add features, we could either add new zaps, we could add additional XAMLs to existing small zaps, or we could slice and dice our zaps if in future as needed. A couple of things to keep in mind with this model. One, when we partition these zaps, we want to make sure that we exercise good care. We don't want to get into a situation where the user is constantly switching between modules. Also, data sharing becomes an important consideration. Now, in the one large zap model, what we have is all the pages can share data using memory. However, now that we've sectioned it out into independent Silverlight applications, if pages are in the same zap, not a problem, they can use memory to share data. But when they need to share data across zaps, then we need to look at, if it's probably simple, then we could use query strings to share information. But if it's more complicated, maybe we want to share big chunks of data, we need to engineer some custom data sharing schemes to take care of that. So a quick review of what we did. We first established a design objective for the max app size, for the browser's max working set size. We looked at various models and finally chose the multi-zap model that early in development. And we also want to make sure that when we started with multi-zap model, we start with at least 2 zaps, even if it's a prototype, just to make sure that we iron out all problems right from day one. With this, right after we finalized the model, what we did was we went on and looked at some coding enhancements that we could do to the model to make life more easier for us. I'm going to invite Roman to take over and give you some details about that.
Thanks, Ramya. So now we've chosen the way that we actually are going to go ahead and partition our application. We quickly realized that we would keep slapping on HTMLs over and over again. Which sounds okay when you have 1 or 2 modules, but once you start getting into 10, 15, 20, 30 modules, or if you want to keep maintaining horizontal scalability in terms of being able to lay out modules, it becomes a tedious and almost impossible task, an unmaintainable task, to keep updating HTMLs. So, for example, let's say the minimum runtime version of Silverlight 3 or 4 has to change. You would have to go and do that in all the HTMLs. So we're not rocket scientists. We're actually just building a line of business applications. So a nice simple thing that we did is we actually introduced a HTTP handler that actually generates the appropriate HTML for us. And then HTML is basically going to be what you would see from the default project HTML that gets created. One additional subtlety that we did introduce is that we externalized the Silverlight object tag information. So minimum runtime version, auto upgrade, all those kinds of things we've externalized to an XML. In addition to that, we've actually also introduced a REST-style API for calling this. And in the process, we actually created a module mapping XML, which means that for every application, you can actually name it something different, something more friendly. So you can have it named one thing in your project, and you can actually name it something more friendly for the URI. This handler at the time of rendering will look for that mapping, resolve it correctly, put the correct path into the client bin, and still generate what you would expect from HTML. So far, we're not really abusing anything from Silverlight, but with these subtle improvements, we are able to now continue to keep slapping on modules relatively easily without having to add any other additional content to maintain. Having said that, we're at the point where now we have a delivery mechanism for our Silverlight applications, or what we're calling modules now, since HQ is our application. So now that we have a delivery mechanism, we realized that no matter how much we love the Silverlight asynchronous programming model, at some times you really want to get some information before your Silverlight application is even going to start up. So a good example, which we'll discuss in a little bit, is how we deploy our web services. So in terms of how we deploy our web services, we don't actually may not necessarily know where the web service endpoint will be to actually start calling out for getting data. So it's a chicken before the egg kind of a problem. So to resolve that, since the SL host is a server-side component, we can actually register a provider, a data provider, a client config provider, that goes and reads up some of the information about where this UX is coming from. It serializes that data. It encrypts that data and sends it over the wire along with the HTML. Correspondingly, we wrote a Silverlight client API that is exactly the way you write that object, you can read that object back. So now we actually are able to keep building up encrypted client config data blocks that can be read before the Silverlight plugin is even loaded up. We can read, once the Silverlight plugin is loaded up, it can go ahead and get that information and start making web service calls. Okay, so at this point, we actually now have our Silverlight application up and running, but we don't really see anything. So what we wanted to do is, what we realized right away is a lot of the people that are going to be working on Silverlight projects for us are going to actually be coming from an ASP.NET background. So we wanted to actually come up with some good common ways that you can actually move around in this application. And so what we've done is we actually created like a common layout. It's sort of like a master page concept from the ASP.NET world. And we wanted to make navigation seamless between the modules. And we'll talk a little bit about something we call a navigation within a use case, which is something like what we have is called a view frame, similar to like a wizard step in ASP.NET world. So if you look on the screen, basically what we've been switching back and forth. You have this is our Silverlight application. Within that, we have our master page. We have a header and a left nav area, and we have different kinds of user controls in the left nav area. Then within that, you have a UX page frame, and within that, you have a page. And within the page, you have a UX view frame. So we'll talk a little bit about the UX view frame. Everything else is pretty much Microsoft out-of-the-box kind of stuff. Okay, so when we talk about the UX view frame, what we wanted was we wanted a nice lightweight navigation between different sub-UI blocks or within what we would call like a use case. So like a master detail scenario. I do a search, I get a result, I select the record, I go to a screen where I fill out the information, I'm done, and I go back to some home page. So that's what we don't need heavyweight navigation for those kinds of things. We want to be able to have a nice lightweight navigation. If you need to be able to jump, you can now also be able to jump and use the regular built-in Silverlight 3 navigation support. So what we've done is we've actually created a couple of navigation links, one primarily for page navigations and one primarily for this kind of like view navigation jumping. So with that in mind, we can now cross around sub-UI blocks within the view. We can jump using the normal Silverlight navigation. And in fact, we can actually jump between modules now with that kind of a navigation support as well. So why do we actually go through all of that? We went through all of that because, like I said, we had anticipated that the people that would be writing our applications would be coming from an ASP.NET mindset. So we wanted to have a horizontally scalable packaging model that has no upper limits and seems like navigating with an ASPX kind of a thing. We wanted to have a master page concept. We wanted to be able to use the page frame, the pages, and introduce this view frame views and any abstract UX concepts. And now we actually have two navigation schemes, one for the regular page frame and one for our lightweight navigation schemes. And in both cases, the way that the XAML is presented is very consistent. So to navigate between a view and navigate between a page is both very consistent. And on top of that, we have extensible logic application level client configuration. With that, let's start talking a little bit about some of our instrumentation, and I'll hand it over to Ramya.
Can you switch spots?
Hmm?
Can you switch spots?
Yeah.
All right. So far, we've talked about how we went about packaging, our design considerations that we laid out, how we packaged it, and some code that we had to write to extend the approach so it would make life more simpler for developers. The next thing we'd like to move on to is a very important concept that's important to any business application, which is instrumentation support. So basically, what do we have? Why do we need instrumentation? Now, we have a typical application. We have the Silverlight on the UI. Silverlight talks to a whole bunch of web services to get data from the server. So there's a web services layer. And then we can safely assume there would be some Windows services running in the background. Maybe there are some batches that are scheduled to run once in an hour, maybe once a day. But basically, any typical application in production has a lot of components. And now if something were to go wrong, it's going to be very difficult to figure out where things are going wrong, what kind of troubleshooting it, monitoring health of the application. All that is going to be very difficult if we do not have some logs such as performance, trace, and error logs. I forgot. So let's look at what are the advantages of having instrumentation. Now, the very first advantage, it could be to monitor the health of a production application. What we do when we go out to production is we monitor, we study the logs for a little while. We arrive at some benchmarks for how long things typically take, how long sequels take, how long pages take. So we get some metrics around those benchmarks. And then by proactively monitoring this performance log data, we're able to find out when things start getting worse, maybe some sequels start getting slow, so we can quickly go in, look at the database, see what could be going wrong there. So this way we are able to monitor the situation and remedy problems before they get very bad. Another advantage is to understand site usage. When we log data such about which pages are getting hit in our application, we are able to understand which pages and which features are more useful and being used by the users. That way we can plan out further feature enhancements by looking at that data. Also, we can understand what times of the day the applications are more used. We can figure out that's useful to plan any kind of migrations and things like that we need to do. Also, we have it's useful to troubleshoot issues during an outage. We have our error logs, performance, trace logs. So that's our first stop when there's a problem. We get to understand what's going on. Instrumentation is also a very important tool during development. A couple of things we can do is, for example, let's say we have the application running in the QA. QA reports an error. And the developer can try and recreate the problem on his box, but it could be an environment-specific problem. It doesn't work. So how do we then manage to figure out, we don't even have access to those machines. How do we understand what's going on? So the way, again, our instrumentation information is really useful. We are able to look at the trace and the performance logs and figure out what's going on and help to fix problems much faster than we could without the data. In addition, performance tuning. As we go through our development cycle, we monitor the sequels and the time that sequels take, the time that pages take to execute. And with that, we are able to figure out problem areas that we could target for performance tuning. For example, in a page, let's say it takes 10 seconds. Okay, not only that, in addition, we'll have information such as what database, what web services are being called. Maybe the page is calling the same web service 10 times, not even realizing it. Maybe it's calling information that it's not even using. Maybe it's calling a web service. Maybe the web service shouldn't be going to the database. Maybe it should be returning some information from the cache, but it's going to the database. So we're able to look at all this information and basically tune the application and make it performant. We log instrumentation information on both the server as well as the client. On the server side, we store it in the database. On the client side, at this point, it's more in memory, so it's lost when we recycle the application. I just want to touch upon our client-side instrumentation a little bit. Like I said, it's stored in memory. So it's going to live as long as the Silverlight application lives. As of now, it's primarily a debugging tool for us. While we develop our application, we are able to look at how it's performing and, like I said, take care of troubleshooting, performance tuning, and things like that. It's implemented as a sparse tree of loggers. It's arranged by in a hierarchical manner by namespace. Since it's a memory instrumentation, the infrastructure enforces some upper limits on the memory usage. It also provides some UI, so we are able to review those logs, like lists of error logs and performance and trace. It also helps to configure the logs and to export logs to Excel. Now, in terms of configuring, we have 2 levels of configuring. We are able to turn on or off the instrumentation at a node level. And also, all our messages have various message levels such as criticality, info, warning, and we are able to configure to only log messages that meet a certain criticality level. I just want to quickly run through a few screenshots that we have. This is our performance log screen. As you can see, each record it records the namespace that's logging this information. the time that was logged, the kind of event that's logging it. For example, it could be a SQL fetch, or it could be a proxy execute, the exact component that's logging this information, how long it takes. And also we have tag 1 and tag 2, which are a couple of placeholders for if scenario-specific component, let's say the reference data list proxy, if it wanted to contribute additional information to the log, it could take care of that. Just also wanted to mention all our logs, they are handled just as one quick entry. It's just one quick line wherever we want to. We sprinkled it at strategic locations in our application. So for example, we have a base proxy that through which all our web service calls are made. So there's one line in there that would record the instrumentation for all our web service calls. So it doesn't have a lot of overhead. This is the trace screen. Again, the namespace that logs the data, the level of the message, and the text of the message. That's our error log screen, the source, the logged on time, and the complete error. We can actually double click on that and get to see the details, the inner exceptions, if any, etc. Okay, having talked about instrumentation, why don't we now move on to some of the enhancements that we made to MVVM pattern. Roman is going to talk to you about that.
Great, thanks, Ramya. So, I mean, we didn't abuse the MVVM pattern, but let's talk a little bit about some of the things, some of the novel ways that we actually employ the MVVM. So we wanted to use MVVM. It's a good pattern for composing view model, and model, obviously, that's the name. So to do that, let's take a look at a simple example where we started. Typically, what you'll see is where you denote a use case container that's like a view, and you would associate a view model to that view. So what we perceived is that we would have multiple user controls living within some view, and then associate a view model to that. But what we really realized is that you have a view model that's attached to some container, which is what we call a view, and then you have sparse XAMLs and co-behinds associated with that. So in essence, what felt connected, in fact, turned out not to be really that connected at all. So what happens is that if you have, so let's go back one. If you have this kind of a view model, as you increase the amount of XAMLs and co-behind that you want to introduce into your use case scenario, or that you want to navigate back and forth against, your view model will become busier and busier. As it becomes busier and busier, it's going to become more and more scenario specific, and you're going to reduce the amount of reusability for that view model. So the next logical step is let's break up our view models. So let's associate a view model with the transaction screen, and we'll have a top level view model. So again, the perception is, yes, it's all very connected. You have a view model, and you have an upper bounded view model in your use case container. Maybe it's showing some sort of heading information about where you are, some context information that view model is presenting, and in the transaction screen, maybe you're associating some business object of some sort to the transactions page. Okay, so this is okay so far. But what happens if I have some information from the search screen that I actually want to share with the transaction screen now? Now I get into a situation where if I wanted to, the only way I can do it is I have to add more properties and methods to the view model. Or, so if that happens, I can't do that because there's already a view model associated with the upper container view. So the reason that is that most of the implementations we see are using data context for their glue. So that's fine for simple scenarios, but as your pages get more and more complex, using data context as your glue for your view model starts quickly becoming not scalable. So at this point, we actually went back to the drawing board a little bit, and we started asking some questions about some fundamental questions about how we want to actually employ the MVVM. So the first question we asked is, what is the true scope of definition, scope, and boundary of a view, what we classically call the view? Now, when we have a composite view like this, how does that actually fit into the larger pattern of the MVVM? Ultimately, who's actually responsible for provisioning the view model? And is the data context a good choice for attaching view model to a view in these composite kind of view scenarios? Now, if we don't use data context, what are our other options in terms of being able to data bind? In addition to that, can we provision the view model using some sort of dependency injection pattern? And ultimately, no matter what we do, we don't want to abuse the pattern itself. So that being said, what we really wanted was, we wanted to have multiple view models being associated with a use case container, or we wanted to have multiple view models associated somewhere down in the individual sub-UI blocks. And ultimately, we didn't really care. The sub-UI blocks should not really care where the view model is being provisioned from. Okay, so now, the perception is this, and the actuality is still the same. But what we've done, is we've actually said to our view model that our view model now becomes a framework element. So rather than using data context, we made our view models framework elements. Now, with that in mind, we have a view model. We can actually put the view model into XAML and as a framework element, attach it to the visual hierarchy. And we can actually have multiple of these view models now associated in the visual hierarchy. And we can have our view now go ahead and using element binding or some sort of some approach like that, actually connecting to the view model. That solves the multiple view problem. Now, the second part of that equation is we wanted to be able to actually have sub-UI blocks be able to reach out to a view model somewhere in that visual hierarchy. So to do that, we introduced the concept of a view model connector. It's a strongly typed connector that associates to a view model that you've defined somewhere in the visual hierarchy. Now, with a little bit of plumbing, not too much plumbing, we're able to now find the nearest view model of the type that I'm looking for somewhere in my visual hierarchy. So what does that allow us to do? That now allows us to split and merge view models as we see fit, because your connector is actually typed. So if I want, I can move it up the hierarchy. If I want my view model to live longer, I can move it up the hierarchy. If I want it to live less, I can move it closer to where I'm actually wanting to bind to it. So, and in fact, I can actually come back in and actually split my view model, move some of it up higher, bring some of it closer, and using two connectors, have one connector pointing to a higher level view model, and have one view model connected pointing to a lower level view model. The way we've done it is you can provision it in XAML, or you can use code. It's not static resource, and it can be attached to any framework element. You can attach multiple view models to any parent UI container. And like I said, you can actually provision it at multiple levels of the UI hierarchy. The best part is that your view model gets recycled for you when you leave the scope of that view model. So when that framework element leaves scope, you'll actually also, your view model gets recycled for you. We've been using triggers, actions, and behaviors with no problems, and probably will work fine with commanding as well when that comes out. So with that, I'm going to hand it over to Ramya to talk a little bit about web services deployment.
Okay, so far we talked a lot about the client-side concepts. We also have in Silverlight, the way the model is, web services form a very important part in the deployment. So we have WCF services. Let's look at how we went about figuring out how to package and deploy these web services. So let's start with a very simple setup. This is what you get when out of the box with the default templates. So we have one web service. There's one website. That website hosts the UX components, the various apps, and it also hosts all the web services that we need to define in our application. It's very easy to set up, and when you add a web service, Visual Studio takes care of updating any web.config entries that need to be made. It also takes care when you add a reference to the web servers in the UX components. It's going to take care of any proxy generation that needs to happen. This model looks great. One thing I want to point out is as you add web services, we are going to have more and more config file entries. There's going to be more and more proxies. So in our scenario, we have about 400 web services. That's a lot of config entries. It resulted in config file bloat, a lot of proxies. It resulted in a lot of code bloat. So keeping that issue aside for a second, I want to touch upon this concept. What we did was we separated the UX portion into a separate website, and the web services portion into a separate website. When we do this, we assume no kind of dependency between the two. For example, we don't assume it's in the same domain. We don't assume that cookies that we drop in our UX can somehow be read in our web service layer. We basically assume they are two different sites. All they know, the only way they are linked is through the contract. What does this do? This is actually it feels like a very simple shift. All we did was throw the two into different sites. It does take a little bit of tweaking. When the default web.config, it requires to be tweaked a little manually to set this up. And also we need to set up a client access policy file on the web services site in order for the UX site to be able to reach it. So a couple of things, but after those tweaks, it's fine. Things start working. Now, having come that far, what we did was we went a little bit further. Instead of putting all our web services into one endpoint, we grouped it by functionality and made different endpoints for each of our functionally different web services. There are a few advantages with this approach. The first advantage is, let's assume api3.wk.com, the one in red. Let's assume that's a pretty ancillary kind of website, a web service. We don't really care for that information. Maybe we use that information to show some informational thing on the left nav bar or something like that. And the application probably could function, 98% of the application could probably function without that site. So what we can do is our UI could reach out to that component, and if that component is missing, we could have some, just show a warning, an informational message that it's not available. But we can let the user experience the rest of our application. So that helps with improving the perceived availability of our application. Customers are happy. Another ease is because we've broken it out, it's easier to plan out enhancements, deployments, migrations. All this stuff is easier to plan out because now instead of a huge website, we have it in various chunks that are independently manageable. This kind of breakup also helps with disaster recovery readiness. Now, if we wanted to make our application DR ready, and if all our web services were piled into one big group, then what's going to happen is we're going to have to make sure that all those web services are DR ready before we can declare that we are DR ready. But if we break it out like this, then what we could do is incrementally add DR readiness to our application. So for example, if API 3 is DR ready, then it could be hosted in the DR. If it fails in the primary, it can fail over to the DR. Application can continue to work. If API 1 is in the scenario, it's not DR ready. So if that was down, then the application would go down. But otherwise, we do have some incremental DR capability built into the system. One more advantage of breaking up the UX components from the API layer is that the UX components are, that area is very passive now. It's a bunch of zaps. And it's useful that as an application grows larger, then it's, that kind of setup is very useful because we can use content delivery networks to push out the UI closer to the customers. Okay, so again, we talked a lot about how we deployed it. Let's look at what kind of code enhancements we did to use this model and make life simpler for our developers. Now, like I touched upon earlier, we had two issues with generated proxies. And the one is there's a web.config file bloat. And as we increase and have like 400 services, it becomes very difficult if there's one entry somewhere that goes wrong. It's really difficult to debug and try and find out which specific little entry in the web.config is wrong. And also there's a proxy bloat, so there's too many proxies, 400 proxies. So what we did was we chose to go with a universal contract. So we have all our web services take a T request and return a T response. And also we also had a universal proxy. All our the functionality for a proxy is built into this one base proxy. And then for every web service that we wanted to implement, we implement a matched set of a strongly typed proxy, which derives from our base universal proxy. It has just one line. It defines the actual physical address of the web service that it's going to reach out to. And also, there's a strongly typed request and response objects, and those scenario-specific request and response objects. So what did that give us? One, because now the strongly typed, rather the base proxy doesn't look into the web.config for anything, so we achieved 0 web.config. And also because we have just this one proxy, we can keep adding web services. We don't have to ever add another proxy to the application. So is everything fine? Absolutely not. We have some issues with this approach that we need to keep in mind while working with this scenario. First of all, there is a runtime parity between Silverlight and core.NET. What does this mean? So we have our web services. All our contracts need to be available to the web services in order for us to be able to program against the request and response objects on the web service. Likewise, our proxy on the client requires access to the request and response objects to be able to read and write to them. And what we need to do, therefore, is because on the one side we have the Silverlight libraries and on the other side we have the .NET libraries, we need to have two versions of all our data contracts, the request and response objects. So what we did with this is, what we chose to do is we put our physical files in the .NET version, and we use linking to create our Silverlight version. So it's a little bit open to developer errors. Instead of linking, we've had scenarios where developers end up copying things over, things like that. So that's something to watch out for. In addition, we need to keep in mind our response object, once request and response objects, these are going to eventually be used in a Silverlight page. Maybe it's fetching data, let's say customer information. It's fetching that to show that data in the screen. Now Silverlight provides us this lovely data binding capability, and so we can just bind in the XAML itself. And for that, what we need is our response objects and request objects need to be bindable. So that's another important consideration to keep in mind. So a quick summary of what we talked about so far. Consider partitioning the UX from the web service. Consider partitioning the web services into individual groups. Consider writing UI that tolerates the service unavailability to improve the availability of the system. Consider writing lightweight universal proxies and universal contracts to reduce web.config entries and to avoid code bloat. And whatever we do, consider this from day one. It's really difficult to rework it at some time in the future, because we might end up putting in dependencies between the two if we don't consider it from day one. With that, I'm going to turn over to Roman. He's going to go through some of the additional functional challenges that we faced and what we did with those.
Okay, thanks, Ron. Okay, so we've talked about a couple of the main key areas that we felt were good starting points for when you consider building large applications like this. There's a couple of other ones that deserve some mention at least. There's no real good data source. Yes, there's RIA, I know. We were not able to employ RIA. In fairness to RIA, it was still in preview stages when we were starting construction. But even now, we have some really sophisticated and complex searches and filtering scenarios that we don't think that RIA can scale up to. So with that in mind, because of the way where RIA was and because of our searching and filtering needs, we weren't able to use RIA. Since we weren't able to use RIA, we couldn't leverage some of the assets that RIA comes with in terms of supporting client-side caching of some records that you retrieve, nice, good client-side paging that comes with RIA, and then obviously auto-fetching. So we actually had to go and build our own, which at least in my opinion, is no small task. So that's definitely one gap that we'd like to see addressed or you'll have to make sure you consider when you're building a large business application. One other is the runtime discovery of composite parts. We evaluated Prism, but its concept didn't really fit into our model because we wanted to be able to recycle, and so that really didn't fit too well. Maybe MEF will solve some of those problems for us. Messaging is another thing that we had to actually either homegrown or use some kind of a toolkit, but it's not really provided by Silverlight at this point. And since our application requires some role-based security that was a little bit out of the box, we actually had to do that as well. Obviously, yes, again, RIA solves some of these problems, but when you have more sophisticated scenarios, those things are really just not there. We had to implement client-side state management, like we already mentioned. And ultimately, when you're building a large business application, you have to consider whether or not you're going to use isolated storage. We didn't actually we didn't leverage isolated storage. We had several concerns around using isolated storage with the line of business application. One is the size footprint. For a larger application like this, we may have to start getting into the business of managing how much space is being actually used, because we can't rely on the user to actually give us more space. And then obviously other considerations that we haven't delved into would be some things if we wanted to actually bring some of those portions into OOB kind of a model. So with that, even though we've had all this fun and challenges and experimentation with building a large business application, we still believe in Silverlight, and we still think that we did a great job, and I'll let Ramya take over for that.
So yeah, so we had this whirlwind tour of all the things that, all the challenges we faced, not all actually, some of them as time permitted. And with all this, why do we then choose Silverlight? I mean, why didn't we just stick to ASP.NET? We've delivered projects very successfully over the past many years in ASP.NET. So why didn't we just stick to good old ASP.NET? The answer is simple. When we first started this project, we actually considered ASP.NET. We ended up estimating how long it will take, what kind of money it's going to take. And we came up with a timeline and budget, showed it to business, and they said, no, this is not going to work for us. We don't have enough budget. This timeline is not going to work. You got to deliver things faster to us. And also, obviously, it's just not faster and cheaper. They also wanted more in that time, just like anyone, any business. So we weren't happy with the budget for the ASP.NET. But I mean, we knew we couldn't go the ASP.NET route with the budget that we had available. We definitely couldn't deliver what we needed to deliver in the compressed timeline. Especially all our scenarios, our pages are highly interactive. When we started this project, we had a contextual inquiry session with our users. We came up with various workflows, and they are all pretty dense. A screen could have about 20 islands of information. Each of those sections could have various things going on, lists, and various things. And with all those interactive workflows, there was a lot of AJAX-style experience coming along. And we found that with ASP.NET, building that much of AJAX, we had a lot of testing to do. Also, we need to support different browsers. That becomes a problem because that adds to our testing, unit testing, as well as our QA testing time. And basically, the same scenarios get exercised over and over in various browsers, various browser versions. And we didn't have time for that. And in addition to that, it's a pretty large application. We had 300 plus pages, and working over this with over 18 months. And we just weren't comfortable. So we started evaluating various options, and we started with Silverlight 2. Silverlight 2, of course, didn't give us a whole lot of things, but we contacted Microsoft. We got onto the EAP program for Silverlight 3, and we found that it was giving us a lot of things that we needed. So we started looking at that, and the couple of nice things that Silverlight gave us to help save on time and time, basically. One thing is, there's a lot of interactive, the binding and things going on. So there's a lot of things that you can do at the UI level. So that reduces the amount of code behind that we need to write. Secondly, it kind of changed our SDLC approach a little bit. It provides a nice separation between the UX and the web service. So in days gone by in the ASP.NET world, what we would do is right after we finish finalizing our screens with business and went on to write use cases, in the meanwhile, we would start a team on to start creating the ASP.NET UI components. Then we would finish use cases, finish design, come in to start coding. The first thing the developer would do is start ripping up the UX layer, because they're also tightly coupled with the code behind and the UX. That tight coupling is kind of broken here. What we did here was, when we started our UX, we also deployed stubs for our web services. So test data was, stub.data was passed to the UX. We were able to take our UX layer to a very high level of completion right there in the UI creation phase. And when we moved on to our development and preparing our services and stuff, we just had to touch the service layer, start now, instead of giving stub data, start giving real data. But the UX layer didn't have to be reworked that much. So that also gave us a time saving that we were able to leverage to reduce our overall time and cost. So with all this, where are we today? We are kind of wrapping up our development phase of our application. We're just getting into an early QA testing. And things look good so far. We have been able to deliver to QA as planned. We are on track. And things are looking good. So hopefully it does look like it was the right choice that we made. All right, so we turn it over for questions. Any questions? If you could please walk over to the mic if you have questions.
Hello, I'm Victor Larsson from Avanade. I have two questions really. First, you talked about SAP files being very large. Have you taken into consideration the global differences? I have a hosted Silverlight app in Sweden, and the load times in the US compared to Sweden is radically difficult. Is this something that you've encountered?
We actually do support across. Our users are typically in US. We do have a few global users, but for our iteration 1, we are looking at mainly a US base. So we haven't had to worry about that to that extent. It's just not a scenario that applies to us. Mainly. Do you have something to add to that?
Do you have any publicly available code samples?
We would love to. It's actually just a time sensitivity for us at this point. We'll coordinate, see where we can do in terms of putting something up onto Coplex. But we'd love to talk and about our ideas and share our ideas and come up with some details. But in terms of some of the implementations and work that we've done, it's sensitive intellectual property at this point.
Okay, thank you very much.
Thanks.
Thanks. We have a very similar architecture and we have faced some of these problems. One problem that we found is the services along with the UX side, and we actually split them. But now what we're finding is if we have too many methods in one of the services, the startup time for the .cf website takes just too long. So we ended up reducing the number of methods, but eventually that will keep growing. And you were talking about splitting the services. What criteria did you use, and did you find any threshold on when to split them?
The way we have it set up with the universal proxy and everything, we have one web method per service.
Okay.
So that's actually one reason why we have a lot of services. But that's the way, because the proxy, what it does is it just knows that given that service, I go there, I call my invoke, pass it the T request, get the T response. So we don't have that scenario where we have multiple web methods.
One method per service.
One method per service.
Okay, and the last question is, do you have any regression testing tools for the UI itself? We use unit testing for.
That's a great question.
Yes, we've complained, cried, begged. I don't know. We're trying to borrow even. Yes, we definitely would like some UI automation. I know that Microsoft is promising something with Test Lab Manager. One thing that looks promising from our perspective, and we don't get any money for this, is Telerik actually has Art of Test. That looks kind of promising in terms of UI automation testing. So we're still evaluating ourselves. We definitely would like to have some, our QA definitely requires some ability to regression test the UI.
Thanks, and congratulations. This looks great.
Thanks.
Thank you.
So that was basically my question. Are you doing anything in terms of validating your binding to your UI set up properly in any type of tooling at all, or is it all human eyes on to make sure that the binding is working the way you expect it to work?
Yeah, so in terms of actually what we can get onto the UI at this point, we don't have any good tool support. So we do our best to have, we do our best to basically manual test at this point. This is something that we would do in the ASP.NET world too, and then we would introduce regression testing once those things have been flushed out by manual eyes. But as of right now, since there are no tools that are doing this kind of automated UI testing, yes, that piece is missing for sure.
Yeah, I was wondering with the initial ZAP, where you had all of your forms in there, how big that was.
I think it came to about 10 GB, no, 10 MB, sorry.
The which one?
Yeah,
which one?
Initial ZAP.
Like a large one?
The 15
so
MB, something
just to
like
give you
that.
an idea, it's approximately, depends on the complexity of your module, it's about 2 megabytes when you split it out. So we have about 30, so you would say 60 megabytes when all things are said and done. You would have, if we went with a large ZAP kind of approach, you could have to consider something like 60 megabytes as an initial download size.
Okay, so you're happy with 2 megabytes?
We're not happy. We're still leveraging, but the idea here is that we can continue to split, continue to leverage assembly caching where we can. A lot of times, some of that is actually because of controls, third-party controls that we're using, and they haven't employed assembly caching yet. So we're working with third-party vendors to make sure that they can give us assembly caching components. And obviously new concepts like MEF are coming in that we haven't really employed yet, but we can probably enhance this existing model.
Okay, thanks.
Sure.
That's a simple question. Now that you said you have started this one 18 months ago, so now that after 8 months now you have MEF, RIA services, all those things are there. So if I want to start a new one, can I use those tools to achieve this?
Yeah, as a matter of fact, we encourage you guys to definitely, we went through a lot of learning. We didn't go into saying that we're going to go in and build our own custom stuff. We wanted to, like Rami said when we were discussing why we chose Silverlight, we wanted to keep things cheap and reliable. So we wanted to be able to use Microsoft components out of the box. We wanted to leverage the ecosystem, third-party vendors who have tested their controls as much as possible. So RIA service is something that Microsoft would provide. Definitely you should evaluate to see if that would fit in your application. But unfortunately, sometimes business scenarios don't always fit into those scenarios. So with RIA services, Microsoft tries to solve world hunger, and sometimes you just want to feed your family, right? So the point is that yes, we want to be able to use a good tool, a good tool like that, and RIA is definitely promising. I wouldn't discourage anyone from learning about how to use those things. So from my perspective, if you're starting fresh, definitely look at RIA services, and if it works out, great. And if you start seeing cracks, then you should start thinking about where you guys can take away stuff from and customize.
The other one is the MDM. I suppose looking at all the MDM things you are doing, have you looked at the MDM Lite and the Carbon and other things?
Yeah. Right. So even the toolkits and things like that, at the end of the day, the glue is really data context, right? At the end of the day, no matter whatever things are happening, the glue is always a data context. So even no matter what container you're using, at any point in time, eventually you're going to set something to data context in code or in XAML, and then you're going to go ahead and start doing that. The problem is that's fine for a simple page, right? When you have one simple page, that's fine. When I have multiple sub-UI blocks, when I have like a good workflow, right, where I have, sometimes I need to go this route, sometimes I need to go this route, sometimes I need to go this route, and I want to be able to share some information between these sub-UI blocks. I can't just rely on one hinge. I need to be able to actually have up front the ability to provision some view models depending on the scenario that I want to do. Plus, if I want something to live a little bit longer, I want to be able to have that kind of flexibility. So we realize that framework element and a visual hierarchy is a really good place to anchor your information. It's not a one-place thing. You can keep putting it in. And in fact, we haven't tried it, but I'm assuming now since Silverlight 4, you can actually use a dependency object. You don't even need to use framework element anymore. You could probably create a dependency object as your view model and put that in the XAML instead of using data context. So the point is that the issue is around data context. So for simple pages, definitely can go for data context. In fact, even in our implementation, if you set a property that says act as if you're binding to data context, it goes ahead and acts as if you've done it to a data context. So if you have a simple screen, you would just go ahead and do that. But what happens is it starts breaking down when you have a lot of different sub-UI blocks, and you don't know up front how you want to go ahead and construct your view model. So what ends up is you're going to have one big, huge view model that's going to encompass all those scenarios. And that's what we started seeing, and that was a big problem for us from a maintenance standpoint.
And you're lucky that you got budget to rewrite the whole thing.
Hi, just a curiosity, since I heard that you guys have 300 web service and they are laying across the domain and different server. How you handle the security?
Yeah. In fact, so SSL is one. And on top of that, we have an implementation of RAP. So the way we're communicating is we actually have an implementation of RAP where we go and get a token, and then with that token we go and make a request to our web service endpoints. So that's how we're actually doing it. So it's actually universal. It's plugged in as an HTTP module. The checks for the proper token, and the actual token provider is a handler that sits somewhere else. So that channel is communicated. Once that's secure and you get a good token, you can go ahead and make the request.
Thank you.
Sure.
Any other questions? Well, thanks all for coming.
Great. Thank
Please
you.
don't forget to fill out our evaluation forms.